Finland is on the verge of becoming the first country to pull off a revolution in nuclear energy. If they succeed, it could change industry standards forever and finally solve a problem that over 50 countries have been struggling with for decades. The idea behind this has been around for ages, and Finland was the only one brave enough to finally pull it off. Now all the experts are saying that the country is at least a decade ahead of the rest of the world. Basically, Finland proved that even a small nation can sometimes handle what might be one of humanity's top challenges. What's the deal? First things first, we need coffee. Just a super unobtrusive reminder to do something, in case you forget during or after watching. And thanks for understanding my desire for you-know-what. So what's the deal? Right now, nuclear power generates about 10% of the world's electricity. On one hand, it doesn't seem all that safe, but on the other, nuclear energy is low carbon. That means it's not as harmful to the environment and might even help slow down global warming. It's all because nuclear energy doesn't require any fossil fuels. Everything's much simpler, and in a way, greener. But I say in a way for a reason, because everything comes with a price. Used nuclear fuel, meaning the kind that's been used in a reactor, is highly radioactive. That's why it's called nuclear, after all. This is pretty much what the fuel looks like. Well, at least the type used in modern commercial reactors. It's made up of small ceramic pellets of low-enriched uranium oxide. These fuel pellets are stacked vertically and encased in a metal shell, forming a fuel rod. These rods are then sent into the reactor to give us their energy. But nothing lasts forever, and nuclear fuel rods gradually become more radioactive and less effective. This happens because of neutron activation as they split, the very process that powers the reactor. After a year or two, any fuel rod turns into a deadly gamma emitter and also loses its main properties. Sometimes the material is used for 3 to 5 years, but the outcome is always the same. The rod has to be disposed of. It's not even safe to get close to unless it's shielded by several feet of water. That's why the used rods are kept underwater. But this constant buildup and the temporary safe storage in pools are a major source of high radioactive waste, making it a big problem. This storage is temporary, which means we need to think of something more permanent and safer than just water. And people have been trying to figure this out for a long time. Dealing with spent nuclear fuel has been a topic of debate since the first commercial use of nuclear energy in the second half of the 20th century. And as I said, over 50 countries are now grappling with this issue. So far, they've managed to agree that each country is responsible for the ethical and legal disposal of its own spent nuclear fuel. But unfortunately, that doesn't make the problem go away, just like the spent fuel. As of 2016, about 260,000 tons of it were being held in temporary storage worldwide. To give you an idea of how much that is, nuclear waste on the planet weighs as much as 26 Eiffel Towers. Most of the spent fuel is located at the reactor sites. More specifically, about 70% is in the storage pools I mentioned earlier, and the rest is in concrete and steel containers called dry casks. It's totally safe. I mean, you can stand next to one of these casks and even touch it, and it won't affect you at all. Meanwhile, inside the cask, the temperature will hover around 392 to 572 degrees Fahrenheit. But the steel keeps radiation securely at bay. Unfortunately, no matter what, this just can't go on forever. In some countries, like the USA, containers with spent fuel are either placed right on the sites of nuclear power plants or at independent storage facilities for spent fuel. There's also an alternative. Spent nuclear fuel can be directly disposed of as high-level radioactive waste. To put it simply, all this fuel can be shoved deep underground and far away from people, so it definitely won't leak into our environment. The United States was planning to dispose of fuel in deep geological formations like the Yucca Mountain Nuclear Waste Storage Site. There, the spent fuel was supposed to be shielded and packed up so nothing could leak out. However, on March 5, 2009, Energy Secretary Steven Chu stated at a Senate hearing that Yucca Mountain site was no longer considered an option for storing reactor waste, mainly because it's a bad option, just like leaving everything in containers on the surface. First off, the scale of the nuclear waste problem is growing every year. A few countries, including the US and the UK, are building new reactors or upgrading existing ones to boost their capacity. At the same time, other countries like India, China, and Russia are planning a massive expansion, so the amount of waste will just keep getting bigger. We've generated 260,000 tons of waste in just 60 to 70 years of using nuclear energy, and we've only been using it more since then. And if you consider that it's partly seen as green, it's scary to think about how much waste we'll have in another 100 years. There's not enough land to fit all these containers. The situation with water is even worse. Just think of Fukushima. They stored radioactive water there for a long time until they realized they simply had nowhere left to keep it. That's it. Space ran out, and it's time to do something else. And that's not all. Spent fuel and radioactive waste remain dangerous to the environment and human health for hundreds of thousands of years. Waste needs to be stored away from people and isolated from the environment for a time that's almost beyond human comprehension. So it's not enough to just dig a really deep hole, toss in a container of waste, and forget about it. Someone has to take responsibility and ensure safety for many generations to come. And not many are willing to guarantee that, so finding an optimal solution's pretty tough. Plus, we just can't think that far ahead. It's quite possible that all the knowledge about this waste and where it's stored will be lost in a few thousand years. So what did Finland come up with in the end? Posiva was put in charge of building and operating an underground storage facility, but a completely unique one. They're using a method developed by the Swedish nuclear waste management company SKB. By the way, that company has already built a similar facility and is in the process of getting a license to operate it. And still, Finland is the first of its kind because it'll be the first country in the world to provide a storage facility where nuclear waste can be safely stored for at least 100,000 years. According to scientists' calculations, direct radiation will decay in about 1,000 years, but even after that, spent nuclear fuel will still harm living organisms if it gets inside. So it needs to stay in the storage. Wait a second, you might say. But what's the difference if they're just planning to bury the waste in the ground anyway? And here's the important nuance. The main idea behind the Finnish storage facility is that in certain places on Earth, like uranium mines, radioactive rock has existed for thousands of years and hasn't impacted people's health and welfare. Now, engineers, together with scientists, are aiming to artificially replicate something like that. The object is called onkalo. It's a Finnish word meaning cave or hollow. It implies something big and deep. You don't know where onkalo ends or if it even ends at all. It's hard to come up with a better name for a massive grave filled with nuclear waste. The construction of onkalo cost about €1 billion, or a little over $1 billion, and its arrival was viewed as a game changer for the whole global nuclear energy scene. But why am I talking in such general terms? Let's take a look at onkalo with our own eyes. The storage facility is located on Olkiluoto Island, about 150 miles from the country's capital, Helsinki. The choice of location, of course, isn't random. This is dangerous nuclear waste, and you can't just bury it somewhere in the backyard of a nuclear power plant and hope for the best. And I'm not even talking about the proximity to people, but about the rock itself. Decades of research into geological conditions have confirmed that the Olkiluoto Island is the best place for final waste disposal in Finland. The state of the bedrock has been deemed suitable to create a facility within it, a combination of shafts and access tunnels at a depth of about 1,400 feet. The construction license was issued by the Finnish government in 2015, but onkalo is set to keep expanding. Ultimately, its tunnels will reach a length of about 31 miles. The storage facility will be built where bedrock cracking and groundwater movement are minimal. And just so you know, these aren't just some theoretical figures calculated by someone sitting in an office. No, there have been some really rigorous tests done that guarantee onkalo's long-term functionality, even in extreme events. An earthquake won't damage the storage facility. Even a possible ice age in the future won't be able to. Now that's what I call reliable. Actually, all of Finland is pretty stable geologically, and the risk of earthquakes here is low. At the same time, the rock around onkalo is really old and super hard. It's almost 2 billion years old. The hardness here plays a really important role, but we'll get back to that later. By the way, Olkiluoto Island, where they're building the storage facility, is home to 3 nuclear reactors lined up right by the sea. These reactors, along with 2 others in the town of Loviisa on the southern coast, generate 33% of Finland's electricity. That's a nice bonus. They won't have to haul radioactive waste all over the country. There's really nothing good about transporting nuclear waste across the country. Most of the time, spent fuel is moved along highways, by rail, or at sea, either to temporary storage or to a reprocessing plant. Since 1971, at least 25,000 shipments have been made. They've covered many millions of miles, both on land and at sea. Here's what a standard transportation route might look like on a map of the U.S. And yeah, containers are usually pretty reliable. Accidents hardly ever happen. Everything's prepped and goes down as safely as possible. Still, I can't shake the uneasy feeling that deadly waste is just rolling around on the roads. How about you? But let's get back to the new Finnish, or Swedish, method of waste disposal. It includes 5 stages. First, the waste is stored in an intermediate storage facility for 30 years. Then it's placed in special cast iron containers, after which these containers are put into copper capsules made of a special alloy. Next, the capsules are set into a layer of bentonite clay in a round borehole that's 26 feet deep and 6 feet in diameter, drilled into a tunnel at a depth of 1,600 feet. Once the storage is filled, the borehole is sealed and the site is marked. Got the gist? Now let's go into a bit more detail. 6,500 tons of spent nuclear fuel will be stored in about 3,250 containers. This storage method is called KBS-3, and it uses several barriers to contain radiation. A canister is the first barrier, with cast iron providing stability while the copper casing prevents corrosion. The second barrier is the bentonite clay around the canister. It's there to soak up surrounding water and expand. At the same time, it keeps the canisters in place, stopping them from sliding around. The third and final barrier is the bedrock itself. The canisters will be lowered underground on a special lift. So far, 5 dead-end tunnels have been built for their placement, each 1,150 feet long. Another 85 tunnels will be built over the coming years as the site gets filled up, and they aren't just holes in the ground. Each tunnel has about 40 vertical round holes in the floor, 26 feet deep and 6 feet wide. In total, about 3,000 canisters can be stored there, one for each vertical hole. After each canister is buried, they'll cover it with bentonite, as I mentioned before, and once the whole tunnel is filled, they'll pack in even more bentonite and seal up the entrance with concrete. Most experts agree that geological disposal for hundreds of thousands of years in specially designed facilities like Onkalo with stable rock formations is the most feasible approach to nuclear waste disposal, especially considering that there's no need to come up with anything new here. Humanity already has engineering solutions for digging and laying tunnels, storing waste, and building barriers. All that's left is to make use of it all. And just so you understand, the durability of the storage is truly guaranteed for the next millennia. For instance, scientists know that there will be several ice ages over the next million years. On top of Onkalo, there's bound to be a 1.2 to 1.9 mile thick ice sheet that'll push the Earth's crust down by hundreds of feet. But the storage was built to handle that. And then the ice age will end. The crust will start rising again, and that's when earthquakes could happen that might wreck the containers. But they plan for that too. The disposal pits are in unbreakable sections of bedrock. By the way, the next similar project will be carried out in Sweden, and then the experience can be used in other countries. Right now, SKB, a Swedish company that came up with a unique method of storage, is working on becoming the second in the world for the safest storage of nuclear waste. The storage facility will be located near the Forsmark nuclear power plant run by Vattenfall in the municipality of Östhammar north of Stockholm. Well, I already mentioned that they're expecting to get the necessary permits, so Finland will be the first country with such a storage facility, Sweden the second, and France is likely to be third. The expected start date for the deep geological repository called SIGIO is 2035. Other countries, including the UK, the US, and Canada, are also considering a similar solution. Why wouldn't they, especially since it looks so promising? But while they're thinking it over and working things out, Finland is already going to start using its storage, getting ahead of the rest of the world. Let's cheer for Finland. And then I had a question. Can't we somehow recycle this waste? Turn it into something useful instead of just burying it? So it turns out that some scientists say that recycling, the process of separating plutonium and uranium from spent nuclear fuel, resulting in reusable material and nuclear waste, is not a bad idea. This way, the waste becomes safer because there's less of it. About a third of nuclear waste in the world has been recycled. After recycling, by the way, it can be turned into glass. At the same time, other experts say that recycling increases the risk of nuclear terrorism, and glassified waste could dissolve when in contact with groundwater and poison everything around in the long run. Plus, recycling is complicated and expensive, and it won't get rid of all the waste. Some amount will still be left over, and we'll still have to find somewhere to store it. But there are even crazier disposal options, like launching nuclear waste into space with a rocket or dumping it in subduction zones. Areas where one tectonic plate slides under another? I don't even know which idea sounds more like an expensive start to a nuclear apocalypse. Yet it should be said that there are critics to the Onkalo idea. Scientists from the Swedish Royal Institute of Technology have expressed concerns about the corrosion resistance of the copper canisters. They claim that their tests prove that copper can corrode even without any oxygen present. Corrosion cracks could lead to the destruction of many canisters in Onkalo in the next 100 years, and then nuclear waste will spill into the ground, and nothing good will come of it. However, Posiva rejected these claims after conducting its own corrosion research. In the article by Posiva scientists and independent experts, they conclude that copper corrosion is considered unlikely in storage conditions. It also states that the corrosion observed in lab experiments doesn't relate to the conditions 1,475 feet underground in Onkalo. Should we breathe a sigh of relief? Microbes keeping us safe. However, there might be something even better than metal containers for storing radioactive waste. It's possible that microbes could take their place soon. We all know that radioactive substances emit harmful ionizing radiation. However, certain types of microbes in the environment have protective mechanisms that allow them to survive in such conditions. These microorganisms can withstand radioactivity and also shield us from its harmful effects, helping to prevent radiation sickness and cancer linked to exposure to radioactive waste. It sounds incredible. But how does this work? First, it's important to note that these microbes not only survive in hazardous environments, but can also transform radioactive substances like plutonium and uranium into safe compounds. This ability can be harnessed for the benefit of humanity by modifying these bacteria, and there's already a successful example of this. The bacterium Deinococcus radiodurans can withstand high levels of radiation due to its effective antioxidants and DNA repair capabilities. Scientists have modified it by introducing a specific gene that encodes a mercuric ion reductase. This allows the bacterium to convert toxic mercury ions into a less harmful elemental form, making waste treatment easier. This is not just for mercury. This approach could also be applied to other pollutants. There are many ways bacteria can help us with dirty work. For instance, microbiologists have developed filters using a layer of Bacillus sphaericus bacteria, which captures uranium ions from soil and liquid radioactive waste. Once extracted, uranium and other metals can be used in nanotech and as novel catalysts. Given that some radioactive elements can take billions of years to decay, finding ways to recycle them is an excellent idea. A new transportation method. According to experts' forecasts, by 2060, active and already shut down nuclear power plants in the U.S. will produce over 140,000 tons of spent nuclear fuel. I've mentioned this before, but it's important to repeat that the volume of waste is incredibly large, and we need to do something about it. In particular, it all needs to be transported, and it has to be done as safely as possible. So even safer than now, because the current level of safety worries me. Work in this field is already underway, and it actually started a few years back. After long development and an investment of $33 million, the Association of American Railroads has approved the use of a new 12-axle system on the largest railroads in the U.S. Yep, this system is specifically designed for transporting hazardous radioactive cargo. The main rail car of the Atlas Company is equipped with a container that's securely held in a 7-ton cradle and fixed with 2 end stops weighing 10 tons each. To safely separate the main car from the 2 pulling locomotives, there are 2 buffer cars. Plus, the train includes a reinforced escort car, which has armed security and communication systems, including satellite, cellular, and radio networks. To ensure the safe delivery of hazardous cargo, the train's equipped with a lot of sensors that continuously monitor up to 11 key operating parameters, such as bearing condition, speed, rolling, and braking efficiency. Plus, the safety and monitoring systems built into the train's design minimize the risks of derailment due to equipment failures or wear and tear. To test the safety of this train, they ran some trials. The train took off on a trip spanning about 1,700 miles from Colorado to Idaho. In the course of the tests, they simulated moving a really heavy cargo capsule that weighed roughly 220 tons, and everything went pretty well. Doomsday scenario. Scientists are warning, if the stored spent fuel catches fire at an American nuclear power plant, the consequences could be catastrophic. Plus, the financial impact could run into trillions of dollars. How did they come to this conclusion? Scientists don't make such claims lightly. They've simulated the fire scenario, and the risks are greater than those seen in Fukushima. Just a reminder that due to the accident at the nuclear power station in Japan, the cores of 3 out of 6 reactors melted down. This led to the release of radioactive materials and contamination of areas downwind. The zone covering 425 square miles was declared uninhabitable, which forced 88,000 people to relocate, while just as many left the exclusion zone voluntarily. Now imagine that the same thing could happen in the U.S., only it would be much, much worse. But why did scientists raise the alarm? Because the fuel, after running its course in the reactor's active zone, keeps giving off heat due to the decay of radioactive products. To cool this fuel down, they store it on-site in special deep pools for at least 4 years. These pools are indeed special, but the protection is still not enough. And if a fire were to break out, for example, at the Peach Bottom nuclear power plant in Pennsylvania, it could lead to the evacuation of about 3.46 million people and contamination of an area covering 12,000 square miles. By the way, that's larger than the state of New Jersey. Add to this the wind that spreads radiation, and 12 months later, we'd have to evacuate a population of over 18 million people from an area now measuring 39,000 square miles. What do we make of this? Well, at the very least, we need to stop storing radioactive waste on the surface. Did you hit a certain button? Thanks. See you later.